Proof 5C. If you didn't get to watch the video on 5A and 5B about vertical angles, I would stop and just make that observation, watch that video, and go up to there. Because we're going to kind of talk about that quick in this proof. But let's go ahead and start this off. It's another similarity proof. And I see I've got a side here, and that's the small one in relation to the other side. And that's going to compare to this small side. And I can see that because, side GL, right, the last two letters, have to correspond to the last two letters, GF, G to F. And I can see that this 5 and 10, they'll correspond, right, E to G and G to K, E to G, first two letters and first two letters. What is missing from this problem, because right now I've only got a side and another side. I don't have this third side or this third side, and inside it looks blank. I don't see any angles. But because we are master geometers, we know that the angle formed by these intersecting blue and red lines, this angle here at G and the angle opposite on the other side, those angles have to be congruent because they are vertical angles. That's how I know that fact. And in fact, that's where I'll begin. I'm going to make my first statement by going 1. I'm going to say this angle here, angle K to G to L, KGL is congruent to angle FGE, this angle here, FGE. And my reason is not given. They didn't put that in my diagram. Nowhere do I see a congruence mark, right? Well, they didn't provide that. We provided that. And our reason for making that bold claim is that they are vertical angles. And that's all you have to say. You could write out angles, or you can do that. And that's enough. We know, oh yeah, definition of vertical angles, those things are congruent. And you telling me their names is how I can go to the diagram and be like, oh yeah, they're talking about that angle and that angle. And that's how we can establish, oh, these angles really are congruent. And now we're ready to do our other sides because we've got an angle, and we're going to fill in these other two sides that sandwich them. So we've got this 3 and corresponding 6. We've got FG over GL, which is 6 over 3, which is 2. And then we've got this side here, that 5, and the corresponding 10. So that would be EG over GK. And that would be 10 over 5, which is in fact 2. So we can write our second statement, which is this ratio of corresponding sides. That's my reason, that's the math I am doing to use this as a proportional side. And then 3. Here's my second ratio of corresponding sides. And when I put these 3 facts together, I can make this claim. I can make the claim that triangle KGL is similar triangle EGF, and I can be confident in that claim because my reason is sufficient. My reason is backed up by a theorem known as the side angle side similarity theorem. I'll see you in the next one. These are where the proofs actually get fun, because there is a little bit of a challenge to it. You have to bring some geometry knowledge to it. They're not impossible because you can see the sides. It's like there's one piece that's eluding you, and that's the pleasure, that's the fun you're going to find in these proofs, or at least that I find in them.